All right, guys, this section is all about being able to find the slope of a line. So we're going to look at a bunch of different ways they can give us some information about the line and us be able to find the slope from that information. All right, so the first way is with a table. So this one shows a temperature of a solution after it's removed from a heat source. We want to find the rate of change. Remember, rate of change is another saying for slope. Okay, those are interchangeable. So if I ask for rate of change, I'm asking for slope. Okay, so if they give you a table of data like this, what you want to do is find the difference between the x's and the y's and divide them. All right, and remember it's delta x, delta y over delta x. Delta just means change. It's a Greek letter for change. Okay, and really we only need two different points. So I'm going to use this one and this one. Okay, so I'm going to do 139.4 minus 143.6, and then I'm going to do 2 minus 0. Okay, you could have done it the other way. I could have done 143.6 minus 139 and 0 minus 2. All right, just as long as the points kind of line up with each other on the top and bottom. All right, so let's actually subtract this. So we've got 139.4 minus 143.6. All right, that's going to equal negative 4.2. And then we've got 2 minus 0 on the bottom, so that's going to equal 2. All right, we don't want to leave it like this, so we want to actually divide this out. Now, with slope, we actually want it to be in fraction form. It's even more important than usual. Normally, I say leave it as a fraction, but you actually want slope as a fraction because if you were to graph this, you want to be able to graph the rise over the run, and that's the top and bottom of a fraction. Okay, so here's what I'm going to do with this one to kind of make it a little easier to get in fraction form. I'm going to move that decimal over 1 to the right. So that means I need to move this decimal over and add a 0. So that changes this to 42 over 20. And then we just reduce. So what are both of these divisible by? Okay, we can divide them both by 2, and we get 21 over 10. All right, you can't reduce that anymore. Top's only divisible by 7 and 3. Bottom's only divisible by 5 and 2. So that's going to be our rate of change, 21 over 10. All right, so here's another example. This one gives us the average rate of change of sales for digital music and ebooks from 04 to 09. Okay, so some of these are points that you can definitely tell, all right, but they're sometimes a little bit off. All right, it's a little bit under. This one's a little bit over. Okay, so rather than try to pick one of these random points here, they give us the actual values on the endpoints. Okay, so I'm going to do the digital music, and then I'm going to have you guys do the ebooks. Okay, so DM for digital music. I've got a point at 2009, 3100. So I'm going to make that 2009 is your X, 3100 is your Y. And I've got another one down here. It looks like 2004 and 200. All right, so this is going to be delta y over delta x. Okay, another way to write that, the slope formula is y2 minus y1 over x2 minus x1. All right, so let's take 3100 minus 200. Okay, again, it doesn't matter what order you do that in as long as you do the same order over here. So then I'm going to do 2009 minus 2004. So 3100 minus 200 is 2900. 2009 minus 2004 is 5. All right, we want to actually divide this out. So 5 goes into 29 5 times. All right, that leaves you at 25, so that leaves you at 40, goes in there 8 and 0. So that's going to be 580 is our rate of change. So every year it's going up by 580 sales. All right, you guys try the ebooks, then unpause it and see if you came up with the right answer. All right, so ebooks, they gave us 2009 is 165.8. And 2004 is 9.6. So that's 165.8 minus 9.6 over 2009 minus 2004. All right, so that's going to equal 156.2 over 5. And 5 into this is 31.24. Okay, 5 into 15 is 3. 5 into 6 is 1. Okay, carries the 1 over. 5 goes into 12 twice. And then if you keep on going, you get 20. 5 goes into 20 4 times. Okay. In the context of this problem, since they gave us decimals to work with, it's okay to leave your answer in decimal form in this problem. Okay, even though slopes are usually better as a fraction. Just kind of depends on the problem. Decimals in the problem, decimals are okay in your answer. No decimals in the problem, probably shouldn't have any decimals in your answer. All right, so back to more traditional mathematical slopes. So we want to find the slope of a line that goes through these 2 points. Okay, pretty much like just what we did. Okay, slope formula, y2 minus y1 over x2 minus x1. All right, so you can pick this to be whatever you want. We'll do x1, y1, x2, y2, like that. All right, so that'll give me 5 minus 3 over 2. Okay, watch out for those double negatives. So there's a minus in the formula, but if there's also a negative on your number, it's going to end up being a double negative. So 5 minus 3 is 2. That double negative makes it a plus. 2 plus 4 is 6. And always make sure to reduce. 2 over 6 reduces to 1 over 3. And again, leave it as a fraction, especially on these math problems that are not word problems. Pretty much the only time decimals are okay is in a word problem situation. Okay, you try this one, see if you can come up with the right answer. All right, just to show you that it doesn't matter which way you do it, I'm going to do both ways on this one. See, I already almost messed up though. All right, so I did 11 minus negative 9. So I'm going to have to do negative 8 minus 24. All right, so that's going to be a positive right there, so positive 20. And this one's going to be negative 32. Okay, they're both negative. You just add them together, keep the sign. All right, let's divide by 2. And we get 10 over 16, negative 10. All right, so I can divide again. Divide by 2 again. I get 5 over 8. So negative 5 over 8 is my final answer there. All right, just to show you that you can do it both ways. So I could have switched these around. I could have done negative 9 minus 11 over 24 minus negative 8. Okay, negative 9 minus 11, they're both negative, so you just add them together, keep the sign. This double negative turns into a plus. 24 plus 8 is 32. All right, now I know I could have actually divided these by 4. Okay, 20 divided by 4 is negative 5. 32 divided by 4 is 8. And you see you get the same answer either way. So it doesn't matter as long as they're lined up kind of on top of each other. All right, find the slope from a graph. Okay, so they give you a graph of a line. You need to find the slope. That means you need 2 points. Got to have 2 points to find slope. Doesn't matter what those 2 points are as long as they are on the line. So look for points that go through a nice point. Okay, you don't want to pick this one because it's like right in the middle. Okay, even though you think it's probably halfway, okay, you never know if it's really exactly halfway. Okay, so try to pick ones where they go exactly through those points. All right, then you literally just count. That's all you have to do. Rise over run. 1, 2, 3 is our rise. And 1, 2. And I went left, so that's negative 2. All right, now usually you don't write a negative on the bottom, so you can either write negative 3 over 2, or if you want to put the negative in front like that. Either way is fine. All right, y'all try this one. All right, looks like we've got a point there and another point here. So rise over run, 1, 2, 3. I counted up, so that's positive. 1, 2, 3, 4, 5, 6, 7, 8. I counted right, also positive. 3 over 8, that doesn't reduce, that's it. Okay, now you may notice that this graph was going by 2's instead of by 1's. Okay, but really it doesn't matter. Okay, as long as both the x and y axis are going by the same factor, you can just count just like I did. Because the only thing it would have done if we counted by 2's, it would have been 2, 4, 6 over 2, 4, 6, 8, 10, 12, 14, 16. And then you would have just had to reduce it back down to 3/8 anyway. So just count by 1's, and as long as the x and y axis are going by the same factor, you're good to go. All right, so last thing is to do an equation. Okay, we know that the slope-intercept form is y equals mx plus b, and we know that m is the slope. Okay, so if we can convert these into y equals mx plus b form, we can just identify that value as our slope. Okay, so to do this, I would need to add 16x over to this side. So I get negative 2y equals 16x plus 41. And then I have to divide by negative 2. So make sure to divide both things over here by negative 2. So I get y equals 16 over negative 2 is negative 8x. 41 is not divisible by 2, so I'm just going to leave that as a fraction. I don't really care about that number anyway today. I only care about m. M equals negative 8. All right, y'all give this one a shot. I know it's got fractions. You can do it. Unpause and see if you got it right. All right, so first thing I'm going to do is just multiply through by a number that's going to cancel out both of these fractions. Okay, that number is going to be 24. So I multiply everything by 24. All right, 24 divided by 6, that's basically what this is 4. So that's 4y. 24 divided by 8 is 3, but I also had a 3 on top, so that's 3 times 3, so that's 9x. And 24 times 24, which is 576. All right, move that 9x over to the other side. And you get 4y equals negative 9x plus 576. And then last step is to divide by 4. All right, and we get y equals negative 9/4. You can't reduce that, so just leave it like that. Plus, and we really don't care what this number is today, so I'm not going to worry about dividing that out. All right, I care about the m right there. M equals negative 9/4. That's the slope. That's the rate of change. That's what we're looking for.